Good morning, ladies and gentlemen. You're very well today. Excuse me. Got a lot of interesting stuff to show you today. Made a lot of progress on the blockchain project. And we're going to kind of focus this in through the lens of the command line interface that I've designed and some of the third-party embedded sources that we are going to use. So first off, let's go ahead and spoil the surprise, the big reveal. The project compiles. I can just type make, and we are going to compile all of the things that I've been working on this week that I will show you in just a few minutes. And now I have it export to this particular path. That way I can just call it by name. And if I just type in blockchain, we get a help message. I'm going to make it a little smaller so it all fits on the screen. Any good program needs a good user interface, right? And this is our little help message. So it's the thing about it is that it's mostly wrong, and it outlines the commands that I have designed into the system. I think it needs some tweaking. I don't think this is quite how they are actually implemented. And also the excuse me. So this isn't quite how they're actually implemented, and pretty much every command has some quirks to it where it's not quite working how I was hoping. So that's okay. What was really useful in the exercise of creating this help message is the planning aspect of it. In order to create this help message, I wanted to be able to list every command that I wanted, all of the input variables, whether you would be able to specify multiple, and this basically gave me a framework for all of the things I needed to build. And what was interesting over the course of this week was that at the beginning of the week, I took a very object-oriented approach to designing this, and I'll show you what I did. Actually, I refrained from making many commits on Git so that I could show you guys this in the stream today. But I was taking a very object-oriented approach to this, and it didn't really make a lot of sense. And eventually, I came over to this other branch, which is, it's called interfaces, or interface. And in this branch, I essentially redesigned the entire program. And quite a lot of work, but I took a more functional approach to it rather than object-oriented approach. And I think it came out really, really well. Let's dig into the differences there by switching over to the original, branch of our repository. So Git Checkout main. I'll make this a little bit bigger for you guys again. Okay, so if we come over to our main repository, we have, this is a little bit too big. I try to make it bigger for you guys. I've had comments in the past of people wanting the text to be a bit bigger, so let me know how it's showing up on your end, and I can adjust the size as needed. But anyway, this is the main file for my original approach to building this command line interface. And what I want to point out are these files here. I was sort of creating these modules, and the module was an object that would have a particular task. So for example, this author. I didn't really implement much here, apparently. I think I did in a different branch elsewhere, but never ended up using it. Anyway, the author was responsible for creating new blocks, and the librarian was kind of the server. It was responsible for storing and retrieving blocks. So this is an object-oriented approach to designing a command line interface. You would sort of divide it into its little modules. Each module will be an object, and then you have your objects sort of interact however they do based on the commands that come in. But I found that in defining objects like this, there were sort of overlapping duties that made this a little cumbersome to work with, and it didn't really make perfect sense in every situation. So let me show you a little more of this main file. Let's see. Okay, so the main file, it's using from my libeom. It's, I think if we do, yeah, I put all of my major includes into this one file so that I can just import this into everything, and everything will be where it needs to be. But in libeom, I have defined a terminal interface that handles pipeline connections and single commands and a user opening a shell interface. And it does this through this interpreter function, which is going to compare all of these different arguments and a lot of interesting things. Hey, Mr. Gamer, good to see you. Anyway, so it does all of these fancy things and all of that. And as you can see, it's kind of messy. It's about as pleasant to write as it is to read. And the interaction between these objects was unnecessary often. It's hard to explain, but it's just this method of working with it. If we think about something that only its job is to write a block, okay, such as the author, and the librarian's job is to store and retrieve a block. Well, the librarian is sort of the server in this case. It's sort of, you could think of it as a database server that's responding to queries. And as a server, what if it wants to create a block about something? Or if it's doing logging of users connecting and making requests, and it wants to make its logs out of blocks, well, then it's going to need to write a block. So is it going to call the author, which is itself a command line interface argument? It's sort of strange. Is it going to call a new instance of the blockchain session? It doesn't make a lot of sense the way they have to overlap like that. So instead of taking an object-oriented approach to it, I switched to a new branch and sort of redesigned the entire thing with a more functional approach. Let's take a look at that. If I switch, by the way, if you're not using Git, here is an excellent example of why you should use Git. So here I have the original repository as it was before I made this significant change. You're going to see in a moment I've changed pretty much everything. I've even every one of these files, I kept these. That's about it. Everything else is different. But I can make a really significant change like that on a separate branch. And then if it doesn't work out, I can just come back to this branch and that's fine. And you'll see right here, I'm just going to say Git Checkout interface. And the whole project is going to update. And now you can see that everything is totally different. So if I go into the main file, this blockchain.c, what this is going to do is just check to see if you are using a keyboard, and if you are, it's going to send you to the command line interface. Now, the first thing you're going to notice is that I prefaced this function with an all caps blockchain. So my thinking here is one of the problems I had with the first version of this, the main branch, was that the terminal interface I used, the generic one that's part of libeom, it was too much. It didn't work very well, and so it caused a lot of trouble and confusion as to what sort of input I was getting. So right now, what I'm thinking is I'm designing only the command line interface, but I am planning this so that I can take different types of input as well later, but to focus in right now on the command line interface. Now, I have prefaced this with blockchain, and that is because in the future, one of the interfaces I want people to have is an actual programming interface. So the same way that I used OpenSSL earlier, where I could specify big numbers or EVPs, Git can restore. Yeah, exactly. So even if I merge this into the main repository, as I will later, actually, where I've never merged something this significant, so we'll see together how that goes. But yeah, so Git, even if I merge it and make a commit, we can restore it back to a previous commit. So if you're not using Git, really, you should consider it. Anyway, so I want one of the interfaces that you can have with this project to be an actual programming interface. So I'm implementing a naming convention that's going to make it really easy to find things. And I was inspired to do this by some of the embedded libraries that we'll look at later, mongoose, for example. It all is contained in this single file, And basically, if I just type in mg, all of these are mongoose things. So by prefacing it with mg, it's easy for me to find all of the components in their library. So I decided to do the same thing, and I've taken it a little bit further and sort of added layers of specification. And it sort of correlates to the arguments you're going to use in order to get around to places. So the first argument in any program, so argc is at least 1 in any program, and argv0 is always going to be the name of the program itself. So in this case, blockchain. So blockchain is our first identifier. And what you'll see is that here in object, for example, I have account and block, and I've changed the names of all of the objects and all of the functions to have this sort of schema of prefacing in the names. That way, if you include this lib chain, then it'll be really easy for you to find all of the things you're trying to work with. Okay, so that is sort of the new naming convention around here, but what's really interesting is the actual interface. So I divided it into functions, basically. Argument count for argv, I mean argc, that's right. Anyway, so I've divided this into individual functions for individual commands. So let me give you an example of a command where I'll walk you through the code, and then I'm actually going to execute it in the command line to show you. So if our first argument is count, then we are going to send it to the blockchain command line interface. I thought CLI stood for client for the longest time, but it stands for command line interface. So blockchain command line interface account, because account is our argument, and then we can go into these CLI folder and we'll go to account.c, and this is the function it called. We pass it argc and argv once again, and now we are going to need to log into a user. That's something I talked about in a previous one, so I'm going to glaze over that here. It does some error checking just to make sure that everything's working out, and the next command should be create. So if it is create, then we are going to actually create a new user account. If it fails, we'll get an error message. If it succeeds, we will get a happy smiley face, and that's it. So if I actually execute this command, first off, let me first say that our blockchain.h file defines our profiles path as my desktop. So in the future, we can change this variable and it'll change the output. So if we look at my desktop right now, it has this test.txt and this block file that I've generated for demonstration purposes. I'll show you that later, but we're going to say blockchain count d8 Eric. Now, do you remember when I said that pretty much every command has quirks to it here? Well, I designed this command so that you would put the username as the last command. And if you don't put a username, it's going to throw an error, I think. But it doesn't actually use it. So actually, it's going to ask me for my username anyway. So that's fine. We'll do that. And now it's going to ask me to put in a new key, or a password for a private key, an RSA private key. And I'm just going to put in test because I'm not going to keep this. It looks like it did actually use that username. So there we go. Account Eric created. And now on my desktop, I have these two files, a private key and a public key. Private key I decided to store in a PEM format. That way we could encrypt it. The private key is not something you're going to be sending around in a block typically, so it's fine to store it in this kind of human readable format so that we can encrypt it. Now, the public key is the thing that we are going to be sending around, so I stored it in a DER or a raw binary format. That way it's easy to embed places. Okay, so now we have an account, and excuse me, let's look at another command line interface function. Oh, it throws an error. Could you demonstrate it? Let's go through all the successful cases first, and then we can try and poke it and make it break. Okay, I'm not really trying to break it at this point. I know there are plenty of problems in it, and I don't really need to find them by breaking things right now. So we'll do that later. Anyway. Okay, so let's look at create. This is the function for creating a new block. This is how you're going to add content to the blockchain. So we have this blockchain CLI create function. So we come down into our CLI and then create.c. Blockchain CLI create. We have our usual error checking and account logging in and whatnot. And yeah, that's all good. We need to specify a previous block though. So the next argument is going to be a previous block. And in order to do that, we are going to need a first block, an origin block. So that's what this demonstration block is. This is our origin block. So I'm going to copy the hash of this block. Now, I've decided that the hash of the block is the file name. And if I actually hash this block, so if I do a SHA-SUM -a512, so SHA-512 on desktop / that.block. I spelled it wrong. Oh boy, I had to go all the way to the beginning. Better to type it again. SHA-SUM -a512. Okay, so we can see that the hash for this block is actually the same name as the block. So it's not that I am storing the hash somewhere in the block. It is that the hash of the block is literally this. And I just named the file this so that it's easy to find. Okay, first of all, it was kind of a pain to pad a string with zeros. I just want to throw it out there for anybody looking for that particular piece of information. Let's go down here. Okay, if you do the same way you can do %0 to specify a padding of zeros for decimal places or numbers, you can do it for strings as well. And for this case, it's a 128 character string, but all of these blocks are mined, so the first digits are almost always going to be zeros. And I want it to actually pad those zeros. So I can pad a 128 character string with zeros and then fill it in later because of this S with the actual hash. So that's how you can do that if you're ever looking for it. Okay, so where was I? That was a sidetrack we didn't need to go on. Okay, the create function. So we are going to we specify our previous block, and assuming all goes well there, we are actually going to create a new block based on it. And we can do this either by specifying this or by specifying from. So from means that you're going to make a block from a file. So you're going to take the contents of a file and store them in a block. Whereas this means I'm going to put something literally into the command line. So I can type in, like in quotes, hello world, and it make a block out of that string. So those are two options I have, and I can demonstrate that. I have this test.txt file that has hello world written in it. And let's I just want to make sure I still have this on the clipboard. First of all, I'm going to print the contents of this block to the screen. And actually, it's going to be kind of weird because it's a lot of raw binary data that's not going to make sense when I do that. But we'll see something at the bottom of it. I want to cat desktop. I need a tilde. You can see it gets some weird output, but we get at the very end here, origin. That's the data. It stores the data at the very end, so at the very least we can see that. Okay, so now I want to create a new block out of this text.txt with this as its previous block. So what I'm going to do is say blockchain create previous block from, and then the path to the file. And I need to give a username. I need to log in order to create a block. So my username is Eric. So it searches for my my 2 keys. Password was just test. And it does some, it prints 1, 2 for some error checking that I forgot to remove. And 2, 3, we have a new block. And let's go ahead and print out the contents of this block. So I want to cat hello world is in this block, and we get a bunch of other random stuff anyway. So we can create a new block. But basically, the point of this isn't to show you these blocks. It's a bunch of random characters on the screen. The point of this is to show you how I broke down the process of creating a command line interface through individual functions. So at each stage, you're going to go through a function. So first we're going to check, is the user using a keyboard? If they are, we send them to the command line interface function. The command line interface function is going to check the arguments that you put in. Did you ask for the account, create, query, read, server, share, etc., etc.? And whichever one you choose, it just sends you off to that function. And when you get to these functions, typically this is often the end of the line, but oftentimes they'll call other functions within them. And so it's, rather than working with objects and thinking about how these objects exist and interact with one another, it's a functional approach. It's going as one object at a time as we are creating things. Okay? So there are a few things that I have not implemented yet. So I think I have this one. Yes. Okay. So I've shown you the naming schema and things like that. The last few things to show you here are the embedded object. But before we get into that, I kind of want to go ahead and merge this into the main branch. So let's talk about doing a significant merge in Git. To be honest, I've never done one before. So I've done a merge in Git, of course, but never something where I've really redesigned the entire project. So let's go ahead over here and let's try it. So I'm going to do Git Checkout and main. Let's just make sure. Okay, and actually there was a point in here where I had a print message that I would like to take out before I merge it. So let's see. Nope, not that. No. Where did that 1-2 come from? I think it came from create. There it is. I see it. Yeah, get out of here. Great. Okay. So as always, the source code is down in the description, and as of that last push, you can get all of the code that I have just worked on, and I am about to merge into the main branch, so you'll see an update there as well, but you can check out the Git repository down there. If you wouldn't mind, while you're there, give that little repository a little star, and just whatever buttons are there to press, go ahead and press them, I guess. Anyway, so we're ready to merge, so let's Git Checkout main, and we're going to git merge interface. Oh yeah, well, it looks like it just worked. Is that how that went? I think that is how that went. Great. Okay, let's take a little look. Did anything go wrong here? A lot of messages. All right, so Git seems to have handled that just fine, which is kind of a testament to why you should use Git, because when you make a significant change like that, you can really, it's really easy to work with. So actually what I can do is git log, and let's see. There we go. If I wanted to, using this hash, I could jump back to one of these. This is actually the history of one of my other branches, so that's fine. But anyway, quit, clear. So anyway, I could jump back to what I had just a minute ago if I wanted to. But anyway, so our merge was successful. So let me show you a few more things. One was that I decided to split off into this one main header file and include all of the different libraries and global variables. Now, these I still want to create a config file for, but I just wanted to put everything in one file. That way, for the most part, like things like standard bool and standard lib and string.h, I don't want to have to include this in every single file. So I just put as the main header file here a link to this. So easy things like that. My personal library and OpenSSL. And then these are the embedded libraries. Now, embedded libraries are a topic I want to talk about here. So in the previous live stream, I was spending a lot of time working with OpenSSL, and OpenSSL is not an embedded library. It is a big library that is installed system-wide, and I'm just accessing the global paths for the global installation of OpenSSL. So what this means is that when you download this project and you try to install it and use it, you're going to have OpenSSL installed first. Okay, this is going to be a requirement. But with these two, Mongoose and SQL, you're not going to need to install them. You're not going to need to download them. You're not even going to need to know that they're there. They are actually packaged in with my project here. And that's what makes it an embedded library. So this embedded library actually exists within the project. I put it in this source folder, and here we have mongoose.c and mongoose.h, and we have dynamic or static. Neither. It is a C and H file. We have a header file and we have a definitions file, and we will compile this with our source code. And in the case of SQL, for example, so SQLite, you're going to see it's going to take a minute to load because this is what's called an amalgamation file. What they've done is they've taken all of the source code for the SQLite database, and they've put it all together in this one huge file. It's, what is it? 234,242 lines of code for SQLite, and this is your SQLite database. And I just compile this along with my source code, and now I can use a SQLite database. And it's the same thing with Mongoose. If we look at Mongoose, OpenSSL, I believe I'm using the static library, a .a file. And I know it comes with some dynamic libraries, and actually Xcode gave me some error messages a little while ago about those dynamic libraries and code signing in relation to things. I don't know, Xcode can be a bit strange sometimes, so I don't know what that was. But anyway, yes, OpenSSL, I'm using a static library. And these, I'm just compiling the actual source code of the project with, what is it doing here? Never noticed this feature before. Anyway. So anyway, you see you get these giant files, but it includes all of the source code for the project. And then you just include the .h file wherever you need it, and you can make things. So the first one I want to show you is SQLite. This is going to, well, actually, let's start with Mongoose, actually. So with Mongoose, now, if you remember, I had created in actually several videos on this channel, several web servers using sockets, and I even created a peer-to-peer web server using sockets. And Mongoose is basically that. It's sort of an API for quick ways of doing socket programming. But the nice thing about Mongoose is that it's pretty robust. So let's see, if we go to the home page here, we can see that Mongoose is used by Windows, Android, Linux, iOS, macOS, QNX. Oh, these are supported platforms, excuse me. Here are their customers: Dell, Google, Hewlett-Packard, Lennox, Intel, Nintendo, Samsung, Ubisoft, Qualcomm. I mean, this is a pretty robust library. And if we look at the documentation for it here, it has some really nice features that will make our blockchain project compatible with other things. And that is really the motivation behind me switching to this third-party embedded library rather than sticking with my own personally developed sockets. I, in this case, am sticking with some of these core features, but we could really easily start using some of these HTTP features or WebSocket or MQTT, whatever one of these we want. We can use any of these pre-programmed protocols and make the server much more robust and much more responsive to whatever we need to do. So by switching to Mongoose, we kind of have this predefined library of protocols that we can accommodate. But largely, we are going to be writing our own protocol here. And that's why we're sticking with the API reference. Thank you for showing it. You're welcome. Anyway, so let me show you how it works. I've broken it into a few separate stages, and I'll tell you why in a little bit. But let's talk about what those stages are. First, there is the initialization. We need a variable to represent our server, and that is going to be this MG manager, so a mongoose manager. And you just create a pointer variable. I call it server. You don't need to make it static. I made it static because I am defining it up here in this blockchain.h. I want to be able to reference it anywhere. So yes, I have this server variable, and we come down here, and we are going to initialize the manager. So mgr init. And don't worry about these two things. This is specific for my use case. And also don't worry about this. Let me change the spacing here to make that a little clearer. You can ignore those for now. After we initialize the server, what we want to do is actually, where is it? Launch it. And what you're going to do is say, where is it? mg listen. So first you initialize mg manager initial init, mgr init, and then you listen. mg listen. Everything that I have in between here, from here to here, if you're trying to make your own Mongoose server, you can ignore all of that code. You want to initialize it, then you want to listen. Okay, so listening is going to, for this particular manager, set a listening address, which I'm putting it together out of a few things, but basically what you want it to be is 0.0.0.0 colon whatever port you're listening on. And this code right here is just putting together a few variables to basically make that. I start off with the zeros, and then I have a colon, and here I'm just putting in the actual port that I want. So anyway, I'm just building it kind of manually here. That's what all this code is doing. Basically, we're going to listen on that address. By specifying zeros, I am opening it up so that other computers on the network can connect and use it. You could also do localhost if you only want your individual machine to be able to use it. But for blockchain, obviously, we want to have these machines connect to each other and talk. So I'm having the zeros. Okay. And then you're going to pass it to other variables. Now, these can be null, but, well, no, actually, they can't be null. This one can't be null. This one can. You need to pass it an event handler. And this is the way that Mongoose works. So before I show you my actual event handler, I want to show you this part. So the mgr poll. A poll is sort of an iteration. After we have established a listening connection on Mongoose, we are going to send it into an infinite loop. I actually have a little thing here to not be quite so infinite, but that's what this code is for, just so you know. Anyway, so in this infinite loop, we are going to just go through these iterations of poll, passing it the server and a number to represent the number of milliseconds between every single iteration of this. So I just called that server pulse, and I put that as a variable somewhere. Okay. Now in poll, it is going to essentially, let's see. We look at the manager here. This is the server, okay? My variable server, okay? And it has a linked list embedded in it, this connections. And essentially, poll is going to iterate through the linked list. Okay, so it's just going to keep iterating through the list of connections indefinitely. And in my case, until we tell it to stop. But if you make it an infinite loop, just forever. Okay, so poll is going to iterate through this cons list. And it is going to check an event. It's sort of an event-driven model here. And let's see. Okay, so for each individual connection, we are going to be looking for a particular event. Okay, or excuse me. When we listen, the event handler is called with each iteration of poll, and the event handler is going to check what the event signal is. Okay, it's a little bit strange, I have to admit, but once you kind of see it working, it'll make a little bit more sense. Okay, so our event handler function gets called for the individual connection. I'm flipping between screens a lot. That's probably not making it particularly easy. So our manager has the linked list of connections. The connection is passed into the event handler function with each iteration of poll. And then we just run the event handler with each iteration over every single connection. Okay, so I hope I'll just let that kind of set in for a second. It's kind of a lot there. I'm trying to find my event handler. Here it is. Okay, so with each iteration of poll, this function gets called. And it is going to basically be iterating through the list of connections, and it's going to send me whichever connection it's on. It's also going to send me the EV. So what event has just happened in relation to this connection? Okay, it is going to send me this EV data and function data. Now, EV data depends on EV, and we can see here, over here in this column, well, I can't highlight it, but this column over here, this is what it is passing in EV data. Okay, it depends on the particular EV that we get. This enumeration just lists things that can happen on the server, particular events, just a list of codes. Okay, and with these codes, our EV data is going to be one of these. And then our function data is going to be something that we can pass in ourselves. So in my case, where do we start listening? I pass it a variable here at the end. So our mglisten function at the end, we can pass it a variable, and it will pass that to our event handler as function data. Okay, and what I do is, you can do whatever you want in this event handler. Sort of the simplest one is illustrated here, actually, in this minimal TCP echo server. What we can see is that it just checks to see if the event is mgev receive. So that's actually a problem in these documentations. That's a typo. It means it should say read. Where is it? Events. Read, not recv. There is no recv event. So typos in your documentation, the Santa. Anyway, so our mgev read, we have that, and yeah, so it gives us our flag. And once sorry, I was showing you this. Okay, once we get a flag that we have received something, it's just going to write it back to you and clear the buffer. Okay, and here we can see a more minimalistic implementation of the server for Mongoose. So mgr init for the manager variable, and then we listen on this particular listen address, and then we enter an infinite loop and this person's waiting 1,000 seconds or 1 second in between 1,000 milliseconds. And you're going to iterate over poll, and every iteration we're going to call this. And only once we have received something from the client will we execute this part of the function. And that's how the whole thing works. It's a bit of an interesting model for a server because it's sort of event oriented, and one connection kind of will end up going through the event handler multiple times. Okay, so there are multiple things that happen when you connect. Okay, I ran a test earlier. I can actually show it to you. So if we go to, well, let's do, I have, okay, so I want to do that. So I have two programs. I'm going to run client over here, and I'm going to run server over here. Okay, so this is a minimalistic implementation, and what it is doing right now, this is going through iterations of poll. And I've set it to basically, if it's just a regular iteration, so we will be getting this event, mgev poll, a 1, essentially. We're just going to ignore it. We're not going to do anything. But for anything else, we're going to print it to the screen. And the client does exactly the same thing. So once I run the client function, it's going to connect to the server function, and they're both going to print out all of their codes. And we can see sort of the order of operations here. Actually, I think this is going to do multiple writes back and forth, so we might have to accommodate for that. Okay, so if I run the client, oh. Uh-oh. Okay, well, apparently I did not leave that in a working condition. That's a shame. We'll move on. Essentially, what it was going to do was just demonstrate the order that things happen in. But it's easy to show you the order that things happen in because it's the order that they appear here, which is making up for the fact that they have a typo somewhere else. That's elegant. Okay, so first on the client end, we are going to resolve. You're going to get a signal for resolve. Well, first you're going to get a signal for poll, that nothing is happening. And then once you give the command for something to happen, essentially you are going to make a request to a server. The resolve flag is sent into the event handler with your connection, okay? And then you are going to get a connect on the client end once that connection is made. And then the server is going to get an accept message or an accept event. The server can then, at this point, basically, as anything can happen. So once the client has resolved and connected and the server has accepted, you can do whatever you want from there. And that's where you can kind of implement your own protocol. Now, there's a little bit more to this connection than I initially showed. It's not just the connection itself. There's a lot of additional things that come on with it. In particular, this label. So you can use the label arbitrarily. See? Arbitrary. Exactly like I said. And you can put whatever you want in there. So essentially, you can kind of think about the flow of an individual connection as being stages within stages. Okay, so in my case, I actually, in my event handler, am not basing my switch on the actual event code I'm getting like they are in this TCP example. So theirs is based on the event code they're getting. I'm basing mine on the label that I have on the connection right here. Okay, so the label is going to set a status for the connection. And I've just kind of written my own out here in this enumeration. I think that's right here, statuses. Okay, so these statuses are going to be different stages of the connection in the event handler. So first, they're going to introduce themselves. Then they're going to, the server is going to find out what it is that the client is looking for. And then the server is going to actually do the thing the client is asking, and then they will close a connection. So these are all the labels. And again, with the functional programming, I have an individual function that's called for each one of these. So if I go into my protocols here, and let's look at the introduction. By the way, I want to talk about where this is happening sort of in the levels of an application. So let's take a look at, no, not TC Palm. I don't know what that is. There's a nice list here of Internet Protocol suites and the different layers of things. So there's the link layer, the internet layer, transport, and application layer. And what we are writing right now, especially in this introduction thing, is the application layer. Okay, so if we look, HTTP is an example of the application layer. And if you think of HTTPS in particular, where there's this exchange of a public key so that they can encrypt messages back and forth, that is going to be very similar to what we do here. But this exists at the application layer. So that is what we are implementing here on the server end. We're implementing an application layer interface for this project. Okay? So we can ignore these variables for a second. Once we get into the label, once we have specified what we want by label, we then specify what we want by this EV. Okay, so if this person has just connected to us, the first thing we're going to do is this introduction protocol. Okay, so the label is going to be that they're waiting for an introduction. And while they're waiting for an introduction, many different events could happen with this connection. They could get an accept, they could get a read, they could get a write, they could get a close, they could get any one of these things. Where are they? Sorry. Events. So any one of these things could happen. And we can specify that while we are waiting for this introduction, while we have the introduction label, here's what you do to a client who's trying to do any of these things. Now, most of them, you just kind of return an error, but you can handle different things in different ways. So first, I use the label to actually specify what stage of the connection we are in. And then once we have established a stage, we go further in and we look at the actual event that is happening on this mongoose connection. So that is kind of how a mongoose works. And it's pretty interesting because it offers quite a lot. In my case, I'm only implementing a very basic version of it. So you can see that this mongoose manager, initialize, and mongoose listen, these are the baseline core functions of mongoose. A lot of screens flipping around. These are the core, just the core parts. But here we can see we have HTTP and WebSockets, MQTT, all sorts of different things that mongoose will allow. And in fact, we can have that do multiple things at once. So if I want my blockchain to serve, or excuse me, if I want my blockchain node to also serve an HTTP website, I can do that here. So that's pretty cool. And I can directly build that in. Let me show you. Right. Okay, right here where I say listen, I can actually give a a second command, I can or I can put in a second server, or even, I guess, the same server. I haven't tried that. Maybe not the same server, but I can put in multiple listen statements and have multiple addresses that this server is listening to. Or I can put it in here. So in my case, everything happens at this exchange. So in the exchange, or in routing, I think, in routing, the user specifies what they want from the server. So this is kind of like putting the URL of the page you were looking for. And once you're here, it uses a dictionary to find the particular route that you're after. And in the exchange, it uses that route, etc., etc. Here we go. It uses the dictionary to get the particular route that you're looking for, and then it executes that in a thread in my case. Why were we going down that path? Yeah, so here I could also put in, I could add a route. Let's see. What I'm getting at here is, let's look at server.h. I've broken this up into a few points. We have our server initialize and our server launch. This is the kind of front end API for this. And if you are building an application that you want to have blockchain enabled, all you have to do is call blockchain server initialize. Then you can use the same server object, use different objects. You can add routes to the server, do whatever you want in between these two. And then you just add blockchain server launch, and all of your things will just merge right into this mongoose web server. So the reasoning behind using this embedded library is that it makes the project extremely portable. Anybody can build something on top of this, add routes to this. You can build your own application and make it blockchain enabled by using this. Okay, so that's kind of our server, and that's the mongoose side of this. But with any good web server, we need a database as well. And this is going to be something that's a little bit different for a blockchain. I don't know other blockchains that have done something like this, but I think this is going to be extremely useful. So our first source embedded library was Mongoose. Our second is going to be SQLite. And SQLite is a database, a single file database. It creates one file on your machine, and you can use it just like any SQL database. And actually, it provides a C interface. It's written in C, and it provides a command line, or not a command line, a programming interface for C. That's actually quite similar to Mongoose. Let's take a look at this database file. Now, fair warning, this file is going to be fairly incomplete. I don't think I've maintained the naming schema throughout the whole thing, but that's okay. I haven't gotten this quite done yet, but that's I'll show it to you anyway. Essentially, we are going to start off with a database variable. I have this defined in blockchain.h, that way it's available anywhere. It's a SQLite 3 pointer I named database. And what we need to do first is make our connection. So we'll call SQLite 3 open. And you're going to give a path to a particular file and a reference to that SQLite 3 pointer object. It's a pointer to a pointer, just so you know. That's why it's the address of. And if there is no file there, SQLite will just create one. So it will create your database for you. And if something goes wrong here, then I have error messages. Otherwise, we're good to go. So after we open our database, we are free to execute some commands. So the first command that I wanted to execute, I've specified a few in this commands file, is to create a table of blocks. So this is just a generic SQL command, create table if not exists blocks. And here we are going to store the hash, the previous hash, the timestamp, size, difficulty, author, nonce, and foreign key here, referencing its previous key. Or you get what I'm going for there. The previous is the hash of something else. So we have a foreign key referencing a column within the same table. It's kind of interesting, but there you go. Anyway, I also have some table. I'm not settled on what the schema for this database is, but this is just sort of what I'm thinking. Is as you get blocks in, so as your server, your mongoose server, this is something I haven't implemented yet, but will in the near future. As your blockchain server gets new blocks coming in, as people start sharing things with you, you'll be saving them to your machine, but you'll also save these header fields to a SQL database. And then you or any other node on the network can execute a query on the SQL database. So let's say you create a block, and an hour later, you want to see if there are any blocks that reference your block and as its previous block. You can send out a SQL query both on your local machine and all of the other machines for any blocks where previous equals your block. And you can get a full list of all of the results. Okay, so we are going to embed the SQL database directly into the blockchain project by using the SQLite embedded library. Okay, so once we have, not there, minimize that. Once we have connected, we can execute commands. So we just SQLite 3 execute, you specify the database and a command to execute. Now, this is if you remember in the mongoose section, we had a callback function. So here we can specify a callback function. Now, in this particular function, I'm creating the default tables, the ones that are just generic. So I don't need a callback function here. I know what these are doing. Generally speaking, we do need a callback function, and they work in an interesting way. So I think I defined a default one, generic callback. Okay, they take a few arguments. First is a callback argument, and I don't think I'm using that here, so let's leave that for now. An integer that is the number of columns, and then an array of strings that is the column text. So this is kind of your results. If you think about the results of a SQL query is going to be a row of a database or several rows. What it's going to do is this callback function is going to be executed over each row. So this num columns is the total number of cells, and this column text is the data stored within those cells. And note that it is column text. So this is a string representation of whatever is in there. So keep that in mind. Okay? And then we have another array that is just the names of these columns. Okay, I don't need that here. So in my case, I just print out the data to the screen and I separate it with columns and a new line for each one. That was all I did in this generic callback, and you can kind of see how they work. If you have a callback argument, then when you execute, this argument would be your callback function, and this would be your callback argument. So you can see I'm not using those here, so I can't really show you anything with that. But it's as simple as this. You open up a database with a specified path. Once you have that connection, you can execute commands on that database, and that's basically it. It's pretty great, and I think this is going to be really useful in a blockchain because of all of the ways that we want to find the relationships between data. And especially since any node can query anything else on this, I can query you, you can query me. This will make it really easy to find things on the network. Now, one of the problems is that there's a security concern in this database. Now, the database itself is not the blockchain. Okay, that's an important point. The blockchain is the files, these block files. Okay, these are the blockchain. This database is just a quick reference of an index of the blockchain, so we can find things faster. Okay, so if this SQL database gets corrupted on anyone's end, no problem. The blockchain remains intact. But there is still a security concern. Just because it can be destroyed doesn't mean I want it to be destroyed. So the security concern comes in this server object. So there are 3 default routes that I have defined for a blockchain server. There is Git. Currently, they do nothing. And Git is going to be where the client wants a specific block from the server. And this is basically going to be the client is going to get a block from the server. Put is that the client has a block they want to give the server. So they are going to put a block on the server. And then SQL is that they execute a SQL command. So the client will send me a SQL command and I'm going to execute it. And you know exactly where the security concern is coming in. I am executing something the user has put in as code. That is a terrible idea. And what I basically need is to make it so that the only commands that a client can execute are read commands. They can query and ask to get information, but they can't write anything. And that is a problem I have found with SQLite, is that it doesn't really offer robust security in that sense. So outside of manipulating privileges on who is running what, and that's going to be a little bit tricky from system to system. We're running out of battery, so the face cam's going to have to go soon. I'm going to need some water in just a minute here. Anyway, we're basically going to be reduced to string checking and just checking any string that the user sends us for insert into or alter table. We're just going to not accept any queries like that from foreign nodes. The only queries we'll accept are select from, and that'll kind of be our security guard against it. Now, if someone is more familiar with SQL queries and any other commands that I would need to look for in order to prevent security concerns like that, please let me know so we can implement them here. Maybe we can get if you open up an issue on the GitHub for this and just have a running list of SQL commands to look out for. That would be great. Okay. So I am going to take a quick break here. I'm going to grab some water and I will be right back. If you have any questions, by the way, feel free to throw them in the chat. We're going to have to lose the face cam as well because my battery is almost out. But ooh-wee, I didn't mean to do that. I don't know what you guys are seeing right now. It's kind of stuck on a sleep screen for me. This is a bit awkward. Well, are we back? Can you guys hear me now? Let me know in the chat if you can hear me. I'm not sure what happened there, and my Mac completely crashed. That was exciting. Always interesting stuff happening in the streams. Do let me know in the chat if you can hear me. It looks like we're good to go. Let me check over here. Yeah, my mic is getting things. It looks like we're still good to go. I'm not seeing anything in the chat, but let's just assume for a moment that it's all going swimmingly, because it has so far. Okay. Yeah, I didn't take a break at all there, so give me 1 second here. Let me grab some actual water. And I was dealing with my Mac crashing. Sorry, give me 1 more second. Okay. All crises are averted. Nobody has let me know that they can hear me in the chat, which is disappointing, but I'm just going to move on assuming that we are good to go, or that I'm just not seeing anything from chat. Okay, so what I want to do right now is actually work on merging these two parts together. So we have our database, we have some create initial tables and all of that, and we have our server, but what I don't have is any connection in the server to the database, and that's what I want to do right now. So what we're going to do as part of this initialization process is actually call the database initialization. So we're going to say blockchain db init, and that is all we need to do. You can see, first of all, that this command was easy for me to find because I've used my naming schema, which I haven't done everywhere, and I need to change. Like, even when I use these static variables, I think it's useful to stick with the naming schema. But anyway, I just need to initialize the database here. That's going to create the file wherever it needs to be, and then I need to start implementing it whenever I get one of these exchanges. So in particular, the get, or excuse me, the put. So we can implement the put routine here. Essentially what we're going to do is read a block from the user and then confirm that it is a valid block, and then add it to our database and write it as a file. So the first thing we want to do is read. So actually we need to check, what are we getting at this point? Okay, so this is going to be happening as a thread function. Let's talk about where this is occurring first so we know what we're dealing with. Okay, so in server.c, pull the event handler. Okay. At this point, we are working on the exchange. So we've already been introduced. We've already gotten the route we want. They've specified the route they want is put, and now we are going to do the exchange. So in our protocols, we can see what happens in the exchange. We wait for a read command. So the user is going to read a... Is that correct? Should it happen in the read command? Let's assume I'm right. Okay, so I think it might actually be helpful if we walk through the entire process first so we can see what's happening. There are some important design decisions that I had to make, and actually they're still up in the air. So if you have any input on this design, let's walk through this entire process. From start to finish, a client connects to my server. First thing they're going to do is they're going to have a block server introduction label. That's just 0. And in particular, we're specifying that on this MG connection, our label, if you remember that that is an arbitrary label. Let's see. MG connection, our label. We have a 32-byte arbitrary label. And actually, it's not 32-byte. If I come down here and I do C label, we can see I actually have 50 bytes. So another error in the mongoose documentation, but we can actually go on to Git and make a pull request to fix that. We can do that later. Anyway, so when we first get in, our label is, I'm assuming the label is going to be null. So when we look at, let me pull up server.h, let's put them right next to each other. Okay, so our label introduction is 0. Okay, that's how an enum works. 0, 1, 2, 3. Okay? So when it first comes in, it should be 0. And what we're going to do is send it over to this introduction protocol. Okay, and we're just passing along all of the exact same variables. This is the same way I did the command line interface with a functional approach. I'm passing exactly the same variables into more and more specific functions. And that's how the whole thing works. So let's go into our protocols and our introduction. Okay, so the first thing that happens, if we remember, is let's look at our events. So first it's on the client end, resolve and connect. And the first thing that happens on the server end is accept. So what's going to happen is it is going to allocate the size of a session and then initialize some variables. Okay, we don't need to worry about the session just yet. Basically, the session, where do I have it stored? Under objects. And our session, basically, this is used when we start doing multi-threading. Don't worry about it right now. And this is basically for logging purposes. It's linking one block to the next. You're going to see how the server speaks entirely in blocks, and this is going to link one block to the next when we are dealing with a client who does multiple commands on the system. Okay, so that's our session. Okay, so where are we? I think I'm showing you introduction. Okay, and we just initialized the session, no problem. And we are going to send a certain block to the user. Now, one thing that I didn't put into this initialization of the server is that we're going to mine a certain block. When you first start your server, I'm going to have it mine a new block, and that new block is going to include some information. Who is the user that is logged in right here? So their public key, and the current external IP address of the node. So it's basically going to identify whoever is currently running this server. Who is running the server? Okay, and what we're going to do when someone connects to us is send them that block. Okay, and then the next thing we are going to do is get a read from them, a read event, because they're going to write their whoami block to us. So we are going to basically exchange information and just introduce ourselves. I give them my whoami block, they give me their whoami block. Now I know who these nodes are. And actually, this is a good opportunity for me to work on connecting the database, because there's a table for nodes in there. But we'll get to that in a minute. Let's go through the entire process. That is our introduction. We exchange a block that identifies us. And what this means is that we'll be able to track the routing of blocks across the network. So if you send one to me, I'm not only going to know what the block is, but I'll have the whoami block of who sent it to me, along with this linked block of all of the events that happen. Where did that go? My objects, it's gone. Anyway, I have that linked block of all the events, so we'll be able to track on this blockchain all of the blocks and all of the routing of blocks because of this introduction. This is the protocol. You could think about this similar to HTTPS, how they do this handshake at first, where they send a private key and they encrypt a bunch of things in the private key, blah, 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 whatever they do. This is sort of equivalent to that, only instead of that, we're sending a whoami block. Remember, the server speaks blocks. Okay. So once we have sent them our whoami block, we are also going to get their whoami block from them. And at that point, we are going to set the status, that is this label that I've defined up here. So that first label, we're going to set it to server routing. Okay, so when we come back to the server, the next time that they go through the event handler, they'll come down to here, and then we'll send them to routing. Over in routing, basically we're going to wait for them to send us something. And what they're going to send us is just something. Why do I say 32 here? I don't know. I think anyway, basically I use this. There's a dictionary. This is one of the dictionary objects that I created quite a little while ago now. So you can check my data structures videos for this. Basically, my routes variable here is one of those dictionary objects, and I'm going to search it for whatever they send me. So there are a few predetermined routes that I'm adding in this. Where is it? Register default routes. These are kind of defined already, but otherwise you can define whatever routes you want for your server. And then when the node connects and they specify a route that they're looking for, we just search that dictionary and see if that route exists, and we store the result of this into a into a variable called route, and this variable is a function pointer. And this function pointer becomes what is sent to our thread. So basically we're going to, this is where things get a little weird. I get this function pointer route, and then I take the label and I actually cast a section of the label as itself a void pointer to this route. And I copy in the route address there. And then I set the label to be exchange. That way when we come over to, when we come down here, we get to this case, exchange. It sends us to this function here. And now our label has a function embedded within it. You can see right here. I can get that label back out. So the result of routing is stored in the label for that connection. And then once they send us another request, we use that route and we send it as a thread job. Okay, and closing just closes it. Okay, so that's the end. That's the whole process. Basically, we tell each other who we are, you tell me which route you're looking for, and then I basically give you that route on a thread. And that's the whole process. So let's come into this introduction, and I want to show you how we are going to interface with the database here. Okay, so when they send us their when we get the who are you block, their who am I block, what I want to do is actually take those fields and insert them into the database. So if I come actually down to, I have a generic command set up, insert into blocks. Okay, so first thing I want to point out about this command is if not exists. So I don't want to overwrite any blocks that are already there. Once I have a block, I should just leave it alone. We've kind of, if it's there, we have done the checks on it, so we're not going to touch it. So we are going to see if that exists. If it does, we are not going to run the rest of this, but if it does not, we are going to insert into blocks hash previous timestamp size difficulty author nonce these values. And here I'm putting in format strings. So I can actually execute that. So what I'm going to do is over in introduction, let's see. Okay, so there, who are you block, we have validated it here. And if it doesn't validate, we're going to close. But if it does validate, then we're going to accept it, and here is where we would put it into the database. But actually, I'm not trying to insert into blocks, am I? I was looking at the wrong command here. I want to insert into nodes because we're trying to insert their data. But we also have the block data, so we have two that we want to execute here. Okay, that's fine. So these are format strings. The first thing I need to do is actually get a local version of them. I keep opening this file. Put this over here. One thing about Xcode, these tabs, I can't get these to be organized in any reasonable way. But so let's see. I want to call one of my database things. So let me do this. I'm going to put space there and save it. That way that doesn't close. I'm going to open this, space there. Okay. Okay. This function, database query, this is what I want. And I have a callback function that I can pass into it as well. So let's see, introduction. Defining that. I need to include it. By the way, I was finding that I could do something like, well, it's not doing it right now, but I could just type in like block.h and it would work within Xcode, but it wouldn't work when you try to compile it. So it's better to actually put these paths. Let's see. I want to go to database/.h. Okay. query. Okay, I see. Okay, so our query, what are we going to query with? Okay, so first we need to format this string. So we'll have a character pointer, we'll call it SQL. And actually, I want to make it, let's give it 512 characters, and we'll set it equal to 0 just to clean it out. And now what I want to do is actually use sprintf, and we're going to store it in SQL. The string we want to use is blockchain db cmd. I don't have these included, so database / setup / command study. That's probably going to have to change. Okay, so, and we want insert into node. That format string. And what are we going to put into it? So let's not do that one first. Because I'm going to have to do some work to get that information out. Let's do the insert into blocks. Let's do that one. That one I can predict a little. Okay, so we are going to want to put into this a few things. So first of all, we look at the actual creation of the blocks. I use varchar, a text field, for most of these things. And for the hash, that's going to involve getting the hash of the thing and of the block, and then converting it from a big number into a text field. So actually, we need to do a little more work on this, because down here, the blocks of value, we need to, do you remember at the very beginning of this stream, for the 4 of you that are here, I showed you how to create a 0 padded string, and we need 0 128 padded string there, and another 0 128 padded string there. Okay, so we can get those 2 strings out of there. Are there any more difficult fields that we need? Hash in the previous we can do. The timestamp is already there. That's good to go. That's good to go. We'll need to calculate that, but no problem. And this one, I have a function that's, so you remember on my desktop here, my account is represented by these 2 files. This one being the private key and this one being the public key. The public key is stored in a raw binary format, which I could in fact put into SQL if I did a blob instead, but part of the problem with doing that is that I can't really cleanly do these insert strings, and it would involve me going a lot deeper into the SQLite API, which I'm not opposed to doing, but I just haven't done yet. So I have a function that is going to take a raw binary public key and convert it to a PEM format. So we can just call that for this. So that's going to be fine, and that's going to be fine. Okay, so down here, we want to got that. Okay, so what are our fields? Let's open up 2 windows here. This. I want commands. Basically, I just want to see the schema for the blocks database here, because I'm not going to remember it. And we've got this. Let's put in our format things. So first we need the actual hash of their block, and we need their previous hash, and they are going to be storing these as 64 bytes in a block. Sorry, let me double check this. Okay, well, hold on. I know this. So, byte. Better. that's going to be our hash. And now I can say blockchain obj block hash, and who are you? Put it in. Okay, so this is going to put my hash in there, and then I need to, this is a raw hexadecimal, and now I need to convert it to a string. So I want to do bn into hex, and our big number, or actually first I want to do big num pointer hash, or let's do hex equals big number new to initialize it, and then bn to our binary to bn. Yeah, there we go. Okay, so our value is going to be our digest. Our length is going to be 64, and our big number is going to be hex. Okay, and now we can say right here as our first argument, oh boy, bn to hex. And then we'll pass it what? Hex. Okay, that's our first argument. Okay, so that gives us the, let's segment this off a little bit more. Okay, and I actually want to bring it back to one window, so let's just close it. Much better. All right, so that's quite a process to get that hash, but actually we know that the previous hash is already stored as a digest within the block. The only reason I had to do this is that we don't store the hash of the block within the block itself, because that would change the hash of the block. So that would become kind of impossible. So we have to get the hash of the block rather than retrieving it from somewhere where it's previously stored. So we do that one, and let's actually, before I forget, go right here. Great. Okay. So when you initialize big num this is from OpenSSL. When you initialize one of these, you have to make sure you free it at the end. I forgot to do this a while ago, and quickly my programs would explode in memory, which was exciting. Anyway, okay, so we have our first one there, and now we need a second one. So big num previous hex equals bn new. Or, you know, I guess we could reuse hex. So let's do that. No, actually, we can't, can we? No, we can't. Okay, so unless I do this. Okay. Char pointer hash equals bn to x. Okay, so let's take a step back and see what's going on here. We've got our digest, and our digest is going to be empty at first, but once we hash it, once we hash this block, it'll be stored here. So we pass it in, and then this is going to store our hash. We're then going to create a new big number called hex, and let's just call this value instead. I like my variable names to be rather clear. So value and value. Okay, so that's our big number. And first we're going to put from binary to big number digest. It has 64 bytes, and it is the value. We're going to store it in value. And then we get as a character pointer that value as a hexadecimal string. Okay, so now we can say big number into bn, not digest, but who are you dot headers dot previous hash will be 64, and we'll store it in value again. We'll reuse that variable. And now I want to put character previous hash equals pn2 hex of value. Okay, so now instead of calling that, we're going to put in hash and previous hash. Okay, we have our first two from the format string, but the rest are pretty easy. So the next one, let's open up our second window again and commands.h so we can see our schema. Okay, we have a hash or previous hash. Timestamp. This one, fortunately, is directly accessible. So we'll have who are you headers dot timestamp. Okay. And our size again. So who are you headers dot size. Okay, difficulty once again. Not size, but oh, we need to calculate difficulty. You know, since we can know the difficulty based on, see what I mean? This is still in flux what's actually going to be in these tables. So we'll just take that field out. So the difficulty is determined by the size. And since there is a one-to-one relationship between size and difficulty, it sort of becomes an unnecessary field. And it's just going to take up additional memory with each row. So it's, you know what, we're just not going to store that field. You could calculate the difficulty. Anyway, so we put in the size. We're no longer doing difficulty. Okay, now the author. So here we need to actually print the key. And I have a function for this. So blockchain object count print. And the user, ooh, okay. So I'm going to need to create an account for this user. So blockchain object account. So we're going to have a temporary account for whoever sent us this block. And remember, their public key is stored within the block. So we can extract it from the block and use it as an account. So let's see. I'm just thinking how I want to do this. So my print function for printing an account assumes that you have an account object, which has a public and private key together. And here, we're only going to have the private key. That might not be a problem. Yeah, I don't think it'll be a problem. So let's just roll with it. Okay, so our client there. And we want to do, so for OpenSSL, in order to get, we want I to D, is that right? I to D or D to I. So we are currently in binary and we want to convert it to the key. So D to I. And we want to do this on their public key. Okay, and our key is going to be client dot public key. The in is going to be who are you headers dot key, and it's going to be 550 bytes length. We load that in, and is that fine? Okay, we can just cast this, that's no problem. Doesn't it like there? Okay. Good. Okay. So we've now loaded our client as an account. So basically we create an account object And then we use this D2I from OpenSSL on the headers or the key field in the headers of the Who Are You blog. This is where they put their public key. So we can just load that directly into SSL, store it in client, and then here, when we want to print the user, we can print address of client. And this is going to convert this new public key format into a PEM, which is human readable. So it'll end up storing that PEM into our SQL database as their public key, and that becomes their primary key, their identifier, their unique ID on the blockchain. What does it not like about this? Argument type void is incomplete. What? Okay, let's rewrite this so that I can see it a little more clearly. Okay, so gone through a few iterations now. So we're going to store it in SQL. And no, that should be good. No, I don't see any problem with that. Argument type void is incomplete. What does that mean? Oh. Oh. Okay. So my print account function. This is what I mean with there's always little quirks. You make something with one intention or one use case in mind, and then you use it somewhere that you forget. So if I write it, that's tricky because I wonder if I can write it to, let's see. I do PEM write. Yeah, send it to a file pointer. That's a shame. Because I would like to have it write it to well, this bio might I like it to just be a string. They don't have a string version of this? I'm wondering if maybe the bio, what is a bio? All right, we're going to Google. Bio is an IO abstraction. It hides many underlying IO details. Oh, well, okay, maybe. I don't know about that. See, I'm trying to put it in a format string, so writing it out to a file doesn't actually help. Let's just look at all the different. Oh boy. I'm just trying to see if there's a way that I can just put it into anything. Just any raw, like like a character pointer, unsigned character pointer, right? You see, the public key as stored in the block is not something I can put in a format string. This is the thing, is everywhere else I'm using public keys. I'm just storing them in raw binary format. And I was saying that in these commands, I can store a raw binary if I use the blob data type. So this author would be a blob data type, but I can't put a blob into a format string. I can't put a like raw binary data of X characters. I know how long it is, so maybe okay. Maybe we do this as a blob. They're not going to be human readable. Wonder if that matters. So when I was printing out these blocks and they were not human readable and they were like making noises on the machine and things like that, it's because they contain raw binary data, and a lot of that data, it doesn't translate to characters and whatnot. And the public key is one of those things that contains that data. So like this contains non-readable things. This PEM format is readable, but I don't have a way to store this to a character. Unless I like put it in a temporary file and then just read it back. That's not great. That's not great. Because it solves it in this case, but it doesn't solve it anywhere else. And anywhere that I want to put a public key into the nodes, I'm going to have to deal with this. So, Also, making it a blob, it makes it less searchable. So if you are looking for a particular user and you have to query for someone based on a blob data type, that's not great. So if we look at the nodes, the public key is the primary key. So it would be better if we could have this. You know what? I wonder, since a public key is a number, I wonder if we could do it numerically. See, one problem with doing a project this big is that when I come up with an idea like that, where okay, maybe I could just use a big num here and get like the hex value or the hex string for this particular field. But the amount of things I would have to make in order to test that, like this isn't that far down the line, but at the very least I have to make a client and and make it so that the client can get all the way to this point and test it. But okay, let's walk through what those commands would be. Just see if it looks right when we this. Okay, so I guess. I mean, that kind of feels right. And then we would just put in the hex value of that. I guess. Let's let's pull this out of the project real quick. And I'm going to touch test.c, and let's do a little test. So, okay, so we're going to need OpenSSL for this. And I'm going to try and copy and paste to kind of make this quick. So, blockchain.h, let's include these. Include these. And I think that's good. Okay, so what I'm going to do is int main. It's going to file pointer f equals open. We're going to open the public key. We're going to try and read it. And then we're going to do evp p key pointer. Let me look at the account function and just load the same thing. Go. Okay, so this is just kind of copying and pasting things, kind of truncating it. So I'm opening this file right here, which is my public key in raw binary format. And we are initializing this EVPP key, and we're going to do D2I public key file pointer. This is going to read our raw binary and store it in an EVPP key. And now I want to try and read that as a big number. So we were doing that right here. Let's just copy and paste this. So I put that there, and instead of this, we just do the key. Oh. Okay, so this isn't quite in raw binary format yet. Okay. So let's do byte. Or unsigned character bytes 550 equals 0. I know that it's 500. I'm using 550 because I know that this file, just having experimented with it previous weeks, is 550 bytes. So I just happen to know that number. And we're going to fread into bytes. 550 bytes once from f, and we can close f, and now we should be able to do. Okay, so first we need big number, big num value pointer value equals bn new. Okay, so now we're going to put our key, but we don't want key, we want bytes. Okay, that should become our new thing, and then we can printf %s \n and bn to x value. Does this actually work? I'm certainly forgetting to link things. Okay. That worked? Okay. That looks like that works. Okay. So why did I think that would work to begin with? So RSA key pairs. That's what these two are. Our accounts are an RSA key pair, and these are basically really, really, really big numbers, and they're prime numbers related to each other in some exponent form, blah, blah, blah. The specifics there aren't relevant here. Point is, I knew that this raw binary represented a number. And since I used OpenSSL to generate these numbers, I figured that OpenSSL could convert them back to numbers. So now our public key can be represented as a hash, or it's not a hash, a hexadecimal string. And do we want to keep it as this hexadecimal string? Do we want to truncate it in some way? You know what, for now, let's just leave it alone. Okay, so let's see. Back here in our example. So we get the digest of what they sent us. We store that there. And now we're going to get the hash of it. Whoops. We're going to get the hash of that. Excuse me. Yes, we convert that hash into a big number so that we can get it as a hexadecimal string. Okay, then we do their previous hash, we do the same thing. Now, big number, binary to big number, yeah, headers key 550, we stored in value, and then character pointer public key equals bn value. And finally, we can put our public key in there. Let's see. We have hash previous, timestamp, size, public key. Nunts. That's our last one. And this one is easy. So, who are you? Headers dot nunts. Go. Okay, so that was a long divergence so that we could get back to here where we finally are going to execute our SQL command. So we're going to execute this SQL command. And you know what? This is going to need way more than 512 bytes. I'm thinking we give it, what is it, 496? That seems right. Because, I mean, how many characters is this? We got to think every single one's going to have that, plus a hash, plus a bunch of other hashes. Each query is going to be pretty long, so. You see, this one already has 1,100, so. I don't know, I think 4 times that is pretty decent. That should be good. Okay, so I'm going to call my blockchain DB query. By the way, we're going to have to shorten this. So maybe I'll have a function in. I'll basically make a helper function to make this a little cleaner. But anyway, we get our SQL statement. We execute. Okay, we're going to execute our SQL statement here. So now we need to have a callback function. And what are we going to make our callback function? So in this circumstance, how are we using it? So this is going to be a protocol, and we're probably going to want to write our rows back to the user. So do you remember over, lost a device, that's okay. So do you remember over here in, where was it? I think it's, in database .seed generic callback. So here we just print each item to the screen, right? But actually in this circumstance, the introduction, we're going to want to write. Oh, actually, since we're, no, I'm sorry, I'm getting confused myself. This command that we're actually trying to put together is insert into, so we don't need to worry about we don't need to worry about callbacks because we're not going to be getting any responses from this. We're just going to stick it in there and move on with our lives. Okay, so getting the actual information was a lot harder than querying the database and putting it in there. Since I had prepared my command template, I was able to just kind of use it to format these fields. But yeah, getting all this information out was a little bit tricky. Okay, so that's basically how we're interacting with the database, and that's going to be happening with the server. So I have a lot more work to do getting more of this actually up and running. But I want to just highlight a few things kind of to review what I was getting at today. First of all, a lot of significant changes have been made to the blockchain project. So if you're interested in the blockchain project, you can check it out on GitHub, which is right here. You can watch it, leave it a little star, whatever you like. And this is where you can follow up on anything that we've been talking about. And also our Discord channel, there should be a link in the description for that. You can come and talk to us about anything that we're working on, and you can see when I'm doing more live streams, apparently, because I will post that. Anyway, a lot of progress has been made, a lot more progress to be made, but really the focus was on designing this command line interface, and that required taking a more functional approach to programming rather than object-oriented. And by functional, what I mean is that I take exactly the same arguments of the function, and I just pass it to a slightly more specific function. So here we pass it to blockchain client or command line interface. I still keep thinking that's client. And then in command line interface, we look at some of these arguments and we again send it to a slightly more specific function. And this is what I mean by functional programming. We're just going further and further down this list until we get to exactly the function we're trying to execute. And we just find it based on the commands. We got that, and we've also made our system quite a bit more powerful by implementing some third-party embeddable libraries, Mongoose and SQLite. I will compile these directly with the blockchain project and have all of their features embedded. And it makes it really easy for us to have a web server up and running and to have SQLite running and make them an integrated part of our system. So I think that's going to be about it for today, and if you have any questions, feel free to join us on Discord. I'm going to have to actually unprofessionally show you the back end here because I lost my second screen. So with that, I'm going to end it, and I appreciate you all being here, and I'll see you next time. Toodaloo.